All right, everyone, welcome back. Today we are focusing on Unit 9, Worksheet 3, where we are integrating our understanding of Lewis dot structures and ionic bonding together. So, I would recommend if you have a hard time drawing Lewis dot structures or missed that part, go back and watch video 1 and video 2. I'm going to go ahead and skip that. These bullet points are also a review, okay? Actually, that's not true. These bullet points are a review, so please go ahead and read those on your own. These videos are extra videos, so if you watch my video and it doesn't make sense, go back and watch videos 3 and 4. I'm going to focus on steps for drawing Lewis dot structures for ionic compounds, and then I'm going to do example 1 with you, and I'm also going to do example 2 with you. And then I'm going to ask you to try and do these problems on the back. So let's focus on steps for drawing Lewis dot structures for ionic compounds. First, draw the neutral atom and their Lewis dot structure. Draw arrows showing how the metal transfers its electrons to the nonmetal. Let's just go ahead and highlight that. The metal transfers its electrons to the nonmetal. Draw the final version of the ionic bond, making sure to show the valence electrons around the nonmetals in brackets, and the charges for each ion. Make sure to stagger cations and anions so that the two of the same type of ion are not right next to each other. So, that's a lot of words. Let's do an example. So I'm going to do the sodium and chlorine example. I'm actually going to scroll down and do it on this blank sheet of paper just because I have more space here. So I'm going to do the example for sodium and chlorine. So the first thing I want you to do is look at your periodic table, find sodium, and find chlorine. And you'll notice a couple of things. They are in the third row, and because they're in the third row, that means we're going to need 3 rings, or 3 energy levels, if we were drawing Bohr diagrams, which I'm going to show you a Bohr diagram and also a Lewis dot structure. So we're going to draw 3 rings for a Bohr diagram. Then we see sodium is in the first column, while chlorine is in the 7th column. And so what this means is that sodium has 1 valence electron, and chlorine has 7 valence electrons. So what I'm going to do is I'm going to do one section to show you the Bohr diagram, and then a second section to show you how does this play out with the Lewis dot structure. Because I think it's beneficial to show both. So what I'm going to do, like I said, I'm going to draw sodium. And we said that sodium has, if we zoom in, it has 11 protons in the center. And it also has 1, 2, 3 rings. And it also has 11 electrons. 1, 2 on the first ring, 1, 2, 3, 4, 5, 6, 7 electrons on, not 7, 8 electrons on the second ring, and 1 electron on the third ring, so that we have a total of 11 electrons. So this is neutral, maybe we want to label it, neutral sodium. And then I'm going to draw neutral chlorine. Chlorine is going to have the same number of rings as sodium, but let's go back and look at our periodic table. If I erase this for a second, make it a little bit bigger. Sodium has 17 protons and 17 electrons in its neutral state. So in the center, I'm going to have 17 protons. And what I'm going to do is I'm going to draw the rings, but I'm going to draw the rings a little bit closer together. And the reason I'm going to do that is because chlorine is going to be smaller than sodium because it has more protons in the center. So I'm going to draw 2 electrons on the first ring. 1, 2, 3, 4, 5, 6, 7, 8 electrons on the second ring, and 1, 2, 3, 4, 5, 6, 7 electrons on the third ring. So that's a total of 17 electrons. 1, 2, 3, 4, 5, 6. Yep, okay. So here's neutral sodium. Here's neutral chlorine. Now, what it doesn't say up here in the directions, is why this bonding is occurring. So what I want you to do is write down, I'm going to write this down because it's probably the most important thing. All bonding occurs so that all atoms have a full valence level. Valence is outermost energy, right? So all bonding occurs so that all atoms have a full valence level. And so if we look at neutral sodium and neutral chlorine right now, we see 1, 2, 3, 4, 5, 6, 7 empty spots in the neutral sodium outermost ring. Remember that this ring is the valence level for sodium right now, and we see it's mostly empty. If we look at the valence level for chlorine right now, we see 7 valence electrons, but also an empty spot where another electron can go. And so we see that both neutral chlorine and neutral sodium have empty spots in their valence level. So remember, I'm just going to go ahead and try and valence, outermost energy. That's the pink energy level, the outermost energy level that I just highlighted. So what's going to happen? What's going to happen is this. Let me use black. Well, not black. Let me use green. This electron, which is held loosely because sodium is a metal and it holds that electron really loosely. Chlorine is good at attracting more electrons. So this electron can come over here and fill chlorine's empty spot. So I'm going to go ahead and draw that. So it's going to fill this empty spot, which means that I'm going to go ahead and erase this. Erase, 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 and I'm going to go ahead and erase that electron. Well, when I erase that electron, now there's no electrons left in this ring for sodium. So effectively, that ring is also erased. So if there's no electrons in that ring, then that ring is also erased. And so now, this is no longer neutral sodium, and this is no longer neutral chlorine, so I'm erasing things now. Instead, we have a sodium ion and a chloride ion. And the reason we have ions now is because the number of positives and the number of negatives are not equal. So here we have 11 positive protons. We just lost an electron, so now we have 10 negative electrons. So this is sodium 1 plus. Over here, we have 17 positive protons and 18 negative electrons because it gained that electron, which means that this is chlorine 1 minus. So now we've just created ions. Well, what was the positive thing about creating ions? Well, now the outermost valence level for sodium has 8 electrons and is totally filled. So let's go ahead and write that down. The valence level is full for sodium. And it's also full for chloride ion. Okay? So that was the goal of bonding, is to get both of these with a full outermost energy level. And once that happens, when they become one positive and one negative, these two things are going to attract, and that's where the ionic bond is created. So that's for our Bohr diagram. But what we want to do is we don't want to draw Bohr diagrams. We want to draw Lewis dot structures. So let me remind you about the Lewis dot structure. The Lewis dot structure, the only difference is that the Lewis dot structure only shows valence electrons. And so I'm going to focus on the Lewis dot structure for now. What I'm going to go ahead and draw neutral sodium. And then I'm going to draw neutral chlorine. And we're going to go through the same process again. So here's neutral sodium. We already said that neutral sodium has 1 valence electron. So I'm going to draw 1 valence electron. Neutral chlorine, on the other hand, right here, has 7 valence electrons. So I'm going to draw 1, 2, 3, 4, 5, 6, 7. So now we can see the 1 valence electron for sodium and the 7 valence electrons for chlorine. And I can make this look just a little bit better. Okay, so there it is. And this helps us see that neither of these atoms has a full valence level. Sodium has 1 too many, and chlorine has an empty spot right here. So, like we did in the Bohr diagram, the sodium is going to come in and fill this empty spot. And when it does that, I'm going to draw a before and after diagram, okay? Sodium becomes 1 plus because it lost that electron. And chlorine is going to have a total of 8 electrons. And so what I'm going to do is we always put it in brackets when it's an anion, and we put -1. So now we have the sodium ion and the chloride ion. Okay? And then what happens is, because this one's positive and this one's negative, they attract each other. And so to draw the final version, I would write sodium 1 plus right up next to the chloride ion. Chlorine 1 minus. This we call an ionic bond. I'll call it an ionic compound. And the name for this ionic compound is sodium chloride. And the reason we call it sodium chloride is because it's a combination of the sodium ion and the chloride ion. Okay? So this is the ionic bond, the Lewis dot structure for the ionic compound. Okay, so that is Example 1. I'm going to stop here, and we can look at example 2 tomorrow, or you can try example 2 on your own, and you can see, can you do any of these problems on the next page? So remember, for these problems, you're really focusing more so on the Lewis dot structure. You do not need to draw the board diagrams. I just did that so you could see the valence level.